Hello everyone, this is Carl. I'm very happy to have this opportunity to present our work. So I'm sorry I cannot do this on live because of the time difference. The meeting will be uh, 5 a.m. or 6 a.m. for me, so I'm sorry about that. My topic is developing a machine learning solution to connect devices to cookies. Um, so this is the challenge for ICDM 2015, so International Conference on Data Mining. Our team, we have 4 people. We got 12th place in the end, so my teammates did a great work for this one, but I'm happy to take the credit to present it. I hope you like this. So a few words about myself. I'm a PhD student of computer architecture at the University of Pittsburgh. Um, Basically, I taught myself about all the machine learning stuff. About 2 years ago, I started learning this online Coursera course from Stanford University, machine learning course. And about 2 months later, I started competing on the Kaggle website. So I guess you guys are familiar with Kaggle and how they host different kind of machine learning contests and data mining contests. So this one is about predicting repeated shopper. So it's also an interesting problem. So about um, so this is the first computation that I won, the first place in Kaggle. So I was very lucky on that one. So basically, there's a data scientist published a benchmark code. So our team just kept improving that benchmark code. So we got very lucky to win this title. So this is the latest challenge I participate, which is also the topic today. So I think it's a very interesting problem. I think we have a pretty good solution. So um, if you are interested on competing on Kaggle, so I have some advice. So first of all, it's very important to reuse other people's code, especially the winner solutions, for future computations. So because the types of problems are uh, are are very common. So it's like a classification problem, a regression problem. So you can always find similar problems and the winner solutions for these similar problems. So and we can also learn a lot of practical tricks and skills from other people's code. So second, it's also very important to find good teammates and form a great team to work together because it always it always works very effectively when you ensemble different ideas or actually ensemble different brains. So it's very effective um, to compete as a team. Okay, so this is the contest, the challenge I'm going to present today. So it's about identifying individual users across different devices. So here we are concerned about 2 types of devices. So the first type are the computers like a desktop or a laptop. So on these devices, on the computers, we access a website or a service through a cookie. The other types are the mobile devices. So here in this challenge, cookie is for computer, and devices stand for mobile devices like a smartphone or a tablet. So a company may be interested to identify users behind different devices, because a customer may access a website from the computer, but later from a tablet or the phone. So the company may provide a better service if they know, if they can identify. So these the same user actually from the different devices. So in this challenge, we are expected to predict which cookie and which cookie connects to which device. In other words, it means uh, this device and this cookie actually belongs to the same user. So, for example, in this case, this user has one device but three different cookies. So we are expected to predict this mapping. Uh, Given a device, we are supposed to predict which cookie belongs to or connects to this device. Okay, so why I choose this topic? Because first of all, this problem is kind of new or kind of unique. So it's not a classic supervised learning, a classic classification problem or regression problem. So if you think about it, um, actually you can think about it how to approach this problem. So because in this case, we are given the task is to predict for each of the 61,000 devices. So for each of the 61,000 devices, we are asked to find the true cookies. And there are 200,000 possible cookies to choose from. So if you use a brute force approach, you can imagine the size of the possible pairs, all the possible device to cookie pairs is very large. So it's very hard to build an efficient solution um, to test every possible pairs. So if you can have a good solution for this problem, so this is a live computation, so it's running now. Uh, Although it seems different and irrelevant from this cookie device thing, but actually it's the same type of problem. So for this one, we are asked to predict which coupon a customer will buy. So, so finally it's the same thing. So for each customer, we are asked to predict which coupons it buys. So it's just like this one. So for this one, for the ICDM, we predict for each device which cookies connects to it. So if you have a great solution, I mean, if you have a very unique approach for the ICDM, I suggest you have a shot. You try it in this coupon purchase prediction. So maybe you have a great chance to win it. Okay, so the data set is also representative. So this one we are given a bunch of relational data tables. So in several recent Kaggle computations, so this data set format is very popular. So in this case, we're given actually we are given 7 CSV files. So this one is generated by ourselves. Um, these CSV files, they gives different information about cookies, about devices, about the IP address, etc. So in each of them, there are several ready features to use, but basically it's up to each player or each participant to decide how to combine these features, how to make use of these features. So that's very important to to mine the information hidden. I mean the interactions and connections between these files. So finally, our team did a great job in this one. So here is distribution of the final private leaderboard score for this challenge. So there are 340 teams in this challenge. So we can see here about 200 teams, their score is close to 0. So the evaluation metric of this contest is F.5 score. The maximum possible score is 1. And on the first place team, they achieved 0.89 F.5 score. And we are here. So it's uh, actually I want you guys to see the trend. So this contest is not the type that everybody are so close, everybody compete within a 0.1 range. For this one, it distributes pretty evenly. I mean, um, all over this range. So um, so that's I think we did reasonably well here. So uh, I hope our solutions can give you some insights about this problem. Okay, so I want to say a few words about the evaluation. So first, we need to keep this in our mind that this is the submission format. For each device ID, we are supposed to predict a group of possible cookies, cookie IDs for this device. So here I want to point out that for a device, it's possible this device has more than one cookies connected to it. So um, we can and it's evaluated by the F.5 score. Um, so basically, for each device, we can calculate F.5 score. So it's calculate based on Formula 1. So here we first need to know the precision and recall. So um, yeah, so P stands for precision, R stands for recall. So precision is defined as the true positives, the number of true positives divided by the sum of true positives plus false positives. So basically, the number of all the positive predictions. And recall is defined as true positives divided by true positives plus false negatives. So if we have precision and recall, and we have this beta parameter, so here the beta is set to 0.5. So for each device, we can calculate this F.5 score, and we can average this score over all the devices. So we get the final score, the average F.5 score. Okay, so the overview of our solution. Um, so basically, we pre-process the data to transform this problem to a standard supervised learning problem. So actually a classification problem. By filtering the possible device cookie pairs. So in the end, we have 700,000 cookie pairs. So the major part of this challenge is to build features, to do feature engineering. So we build several types of features. I will talk about them in detail later. So the classifying is pretty simple and not interesting at all. So everybody uses XGBoost now. And um, it also requires a post-processing stage because we need to translate the probability predictions to the predictions for the IDs. So I will also explain what it means later. So after that, we have a standard submission file. Okay, so about pre-processing. So the idea is very straightforward. So instead of um, finding the true cookies for each device, we first find some candidate cookies for each device. So it could be much simpler. So a candidate cookies is simply defined as the cookies that share the same IP as the device, the same IP address with the device. However, we ignore some public IPs. So our definition of public IPs is the IP address that connects with either more than 15 devices or 30 cookies. So after that, we can transform this problem to a standard binary classification problem. So basically, for each device, we find a group of candidate cookies. So we have a device cookie pair. So instead of finding cookies for each device, we predict the probability of a device cookie pair to be a true pair or a false pair. So it becomes a binary classification problem. So in the training set, we are given 142,000 devices, and based on this criteria, we reduced them to 900,000 device cookie pairs. So in these pairs, we may see, in most cases, for each device, we have several candidate cookies. So we have more device cookie pairs than the number of devices in the training set. Okay, for feature engineering, so first we build these feature vectors for each device cookie pair. So after we have the feature vectors, we calculate the distance features and similarity features. So, but the important thing is how to build this feature vector. So I will talk about it later. And another idea that gives us a very good improvement is this TF-IDF features. So the basic idea behind this is that if a device and cookie shares something, and if they share something that's very common or that happens frequently, it's not very useful. So, but if the device and cookie share something that's not frequent, that's rare, so that's a useful information. So that indicates this device and this cookie may actually belong to the same user. So another interesting idea we tried is feature augmentation. So I will explain all of them in detail. Okay, so first about build feature vectors. So we are given this device and cookie basic information table. So there are some features given to describe each device and each cookie. So basically, there are three numerical features and three categorical features for a device or a cookie. The meaning, we don't know the meaning, so they are anonymous features. And there are some other features for the device and the cookie. So there are also features given for the IP address. And actually, there are more features for this one. So for each IP address, we are given 6 features to describe the general behavior on this IP address. Okay, so these features are also anonymous, and we are given 6 features to describe a particular device behavior on this IP address. It's like how frequent this device access this IP address, etc. And we given the same 6 features for a cookie on this IP address. So the same meaning as the device IP features. So because our goal is to connect try to identify the connections between the cookie and the device. So we can calculate actually the difference between these 6 features and these 6 features. So we can think of these 6 features as a feature vector for the device, and these 6 features for the feature vector of a cookie. So we can calculate the difference of the vectors. We can calculate the L1 and L2 distances of the vector, so the first order and the second order distances. And we can also calculate the cosine similarity of the device IP feature vector and the cookie IP feature vector. Okay, so after we have these feature vectors, we need to aggregate them. So the reason is that for each device and cookie pair, so they may share more than one IP address. So, for example, my laptop and my smartphone, they access the internet at my apartment, so that's one IP address. But I also bring them to my office, so they shares another IP address. So for each IP address, we have these feature vectors. So if the device and cookie shares more than one IP addresses, we have a group of feature vectors describing this device cookie pair. So, um, so we can find the mean. So this is what we did actually to aggregate these feature vectors belonging to the same device cookie pair. So we calculate the mean vector, we calculate the standard deviation, maximum, minimum, and median of the feature vectors. So I think you get the idea. And I want to, show you a little bit of the code, so to see that how this is actually done. So it can be done in a couple lines of code. So the basic paradigm is a merge, split, analyze, combine kind of thing. So basically, we can use the pandas Python library for data analysis to process this problem. So for example, we have this file, this IP device features file. So it describes how the device's behavior on a particular IP address. And we have another file to describe cookies behavior on a particular IP address. So, so first we merge these 2 files. So by the same IP address. So we merge the files based on if they have the same IP address. So next we can build some new features. So here, for example, we build a feature called count IP. So it simply counts how many times an IP address appear in this new data frame. Okay, so at this point, we can see at this point, so we merged 2 files. We have built some new features, but we need to keep in mind that for each device cookie pair, so the feature, it may have more than one feature vectors, as I explained in the above slides. So the next step, these 2 steps are the merge thing. So at this step, we need to aggregate. So we need to split them based on. I'll use the pandas function group by to split them based on ID. So here, this ID means a device cookie pair. So it's an ID for device cookie pair, and we split these data frames to groups of device cookie pairs, and we aggregate the feature vectors for each group. So in this example, we calculate the mean vector of the feature vectors for each device cookie group. So after that, we can um, combine the new features. So we have um, the final data set. So in the final data set, each device cookie pair only appears once, but we have the relevant features. So this is a very simple, this is just a toy example to show how things are done. So it's, I hope it is clear. So, okay. Um, so after the previous step, we have uh, uh, like 100 features or something, so which can already get a pretty good score. But in the near the end of the contest, so we are still um, we're still behind the top 10 teams. So we at this point we had this idea inspired by a post in the contest. So it's about this TF-IDF features. So because we didn't have much time at this point, so all we had is a desperate try. It is not done very, very carefully, but it does help. So it did help. It actually gave us 1% improvement by adding this TF-IDF feature. So which is significant near the end. So what we did is for each device cookie pair, we make a document. Okay, so but it's actually very dumb. So in this document, we have it's just a bag of words, simple bag of words model. So the word or the token in this document is just the raw features. So the raw features of the 7 CSV relational data tables. So we build each token as the feature name plus the feature value, such kind of thing. So we build it this way so we can tokenize each document and then apply the TF, IDF, and SVD um, transformation to it. So these two functions are very standard um, tools for in the natural language processing uh, scenario. But in this case, as I mentioned, so because uh, it is useful because like what I said before, so if a device and the cookie they access the same website, so if the device and the cookie they access Google, that's not very interesting information because Google is very frequently appeared in uh, all the devices accesses. But if the device and the cookie they access a very unique, very uncommon website that may indicate that the device and the cookie belong to the same user. So after applying this TF-IDF and SVD, we get another 100 features. So they turn out to be very effective um, in the end. So another trick that works is feature augmentation. So the idea is very simple because uh, we transform this problem to a binary classification problem. So the instance of this classification problem is device cookie pair, but each device may have multiple cookies. Uh, so like device 1, device 1, cookie 2, something like this. But the classifier is not aware of um, device 1, cookie 1, and device 1, cookie 2 are actually for the same device. So here we define this so-called sibling cookies. So which simply means um, if cookie 1 is a candidate cookie of device 1 and cookie 2 is also candidate cookie of device 1, cookie 1 and cookie 2 are sibling cookies. So um, if we after we have all the sibling cookies for each cookie, we can append the sibling cookies features to each device cookie pair. So it's like if cookie 1 and cookie 2 are sibling cookies, we have a device cookie pair, device 1, cookie 1. We will append cookie 2's feature to device 1, cookie 1. So likewise, we will append cookie 1's feature to device 1, cookie 2. So in the end, for each device cookie pair, we will add features from 3 sibling cookies. So we actually researched this parameter. So if a cookie has fewer than 3 sibling cookies, we will simply add none or any placeholders to the sibling cookies features. So in this way, we hope that the classifier can see uh, more cookies. For each device, the classifier sees more features about this cookie and its sibling cookies in one instance. So it helps the classifier to do a better job classifying the pairs. Okay, so in summary, in the end, we have built 415 features in total. So all of them are numerical features. So it's yeah. So they are like the original anonymous features plus the difference features, the distance, similarity, TF-IDF, something like that. But all of them are numerical features. So the most important features are all about IP. So the IP address is the most critical thing. So the most important one is the number of device cookie pairs connects to each IP address. So here in this figure, we show the feature importance discovered by XGBoost. So this feature, yeah, it's dominantly important. So this is this one. So the number of device cookie pairs on this IP address. So that's the most important feature overall. So after we have a prediction probability for each device cookie pair, we need to post-process this result to get the final result. So this is the result of the predicting the device cookie pair. So we have for each pair, we have a probability predicted. But the final result we want is like this. For each device, we give a list of cookies as its true cookies. So here, this translation, so it takes more than just the thresholding. So, for example, maybe we will take both cookie 1 and cookie 2 as the true predicted cookies, but we will only take one candidate cookie of device 2 as the true final predicted cookies. So we tried several different options, but this is our final algorithm. So we always select the cookie that has the greatest probability. So like this, for device 1, we choose cookie 1, and for device 2, we choose cookie 3 without doubt. So, but for other cookies, we will also choose them if they meet some criterion. So first, we denote the maximum probability as Pmax. If other cookies, their predicted probability is greater than 0.75 or Pmax divided by 1.35, we will also choose that cookie. So these two parameters can also be researched in the cross-validation. So we built a local evaluation system of the average F.5 score, and we researched these two parameters, so to find the optimal parameters. Okay. So that's almost it. So that's how we approach this challenge. So the key takeaway for this challenge is to never use the same IP with your laptop or your mobile devices, because your privacy may be violated by a evil program developed by coders. So yeah, keep that in mind, please. Okay, thank you very much. I'm sorry that I didn't have much time to prepare for this talk. I hope I give you a basic idea of what this challenge is about, and our solution, how we approach this problem, and our solutions. So if you have any further questions, so please email me. This is my email address. So thank you very much. Have a nice day.